Okay, so we started with tuned amplifiers in the last class, and today we are going to focus more on single tuned amplifiers. Okay, so generally, you know that a tuned amplifier will have an LC parallel circuit in your collector side, which is going to act like your load. So the moment the amplifier becomes a tuned amplifier, it is going to produce a peak gain only at one particular frequency. So there is only one frequency where the gain is maximum. All other frequencies, the gain will be less than the peak value. Okay, so if you are not sufficient with your gain, which is obtained from a single stage, we can cascade more number of stages of your single tuned amplifier. Okay, so if you feel that the gain is not sufficient from a single stage of a tuned amplifier, you can have more number of tuned amplifiers in cascade. That is also possible. And tuned amplifiers can be classified into three types majorly, as shown here. One is single tuned amplifier, double tuned amplifier, stagger tuned amplifier. So single tuned means, as the name implies, single means one, tuned means you know. So it is going to have only one LC parallel circuit in the collector. So see here, single tuned amplifiers use one parallel resonant circuit. Resonant circuit means you know it is going to be the LC parallel circuit in as the load in the collector side. So if you are going to use more than one stage, you will have that many single tune amplifiers, and all the tune circuit are tuned to the frequency. So first amplifier or LC will be tuned to the F naught, means second amplifier is also going to be F naught. Third one is also going to be F naught. So this is all with respect to cascading. If you say a single tune amplifier only one stage, means you will have only one LC circuit and F naught equal to 1 by 2 pi root of LC. Clear? So double tuned means double means two. So it is going to have two LC parallel circuit in your collector side. So when you say two LC parallel circuit, it is going to be, you need two inductors and two capacitors. So the moment two inductors come, you will naturally go for transformer. So you are going to have a transformer in the double tuned amplifier, and one end of the primary will act as one inductor, secondary will act as one inductor. Across primary you will have an LC parallel, across secondary you will have an LC parallel. Both the primary and secondary tuned circuits will be tuned to the same frequency. So slightly double tuned will become even more complex when you compare to single tuned amplifiers. Single tuned is very simple, only one LC parallel circuit in the collector. Double tuned, yeah, I'm going to have two LC parallel circuits. So the best way of using two LC parallel circuit is using a transformer. So transformer has two inductors. So you just need to attach two capacitors parallel to the inductor. So it will become double tuned amplifier. One condition is both the LC parallel circuit should be tuned to the same frequency. That is the condition for double tuned amplifiers. If you're having more number of double tuned amplifiers in cascade, all the LC parallel tuned circuits, whatever you have in double tuned amplifier, should be tuned to the same frequency F naught. Okay, so this is the condition you have to remember for single tuned and double tuned. For stagger tuned, this equal F naught condition will be slightly deviating. So we will study about stagger tuned amplifier more detailed after completing single tuned and double tuned. See here, stagger tuned will have more number of singles. It is a single tuned amplifier in cascade, but all the stages will be tuned to slightly different frequency. So if the first stage is tuned to 500, second stage will be tuned to 500.1. Third stage will be tuned to 500.2. So they are all tuned to almost same frequency, but there is a slight difference between the frequency between one stage and second stage. That is going to be stagger. Staggering means there is some lag or delay between one circuit and other circuit. So that is that delay we are representing it as a frequency change. So if you're having three stages of stagger tune amplifier, all the three stages will have different value of F naught, but all the three F naught will be very close to each other. Okay, so all the F naught will be very close to each other. Please understand that. So these are the three main categories of a tuned amplifier: single tuned, double tuned, and stagger tuned. So we will narrow down now for single tuned amplifiers. So single tuned amplifiers are further classified into two types. I'm going to have capacitance coupled single tuned amplifier and transformer coupled or inductively coupled single tuned amplifier. So we are going to focus more on capacitance coupled single tuned amplifier. We don't have transformer coupled because it is going to be even more difficult to realize a transformer coupled single